Hi, everyone. It's my pleasure to provide solutions to the AMC10 12 practice of this week. You can call me Dr. Yu. I work at a UCI Department of Statistics. When you think about statistics, it's not only mean, median, or mode. It's more than that. I enjoy talking about math with young people. Last year, I coached the sixth graders of Turtle Rock Elementary for math counts. The team did pretty well. Two students qualified for the state competition, but due to the pandemic, they were not able to attend it. I hope things will go back to normal pretty soon. I would like to spend a few minutes on how to use solutions. When I'm telling you this, you might wonder, I know how to use solutions, right? I study solutions, but the thing is that how to study it. I also often tell this to graduate students, especially students in their first year. The pace is much faster. The material is much more challenging. A lot of them struggled. So if we use solutions in a better way, we will be able to make more efficient use of our time and also material. Say you have a problem, you didn't know how to do that, then you see the solution. But if I ask you a similar problem, maybe you're not able to do every single step. You might get stuck somewhere. That is pretty common. That is because when every single step is there, our brain doesn't need to think about what is the next step. We don't make mistakes because the solution has been double checked, right? Everything's there. So in that situation, your eyes process the information to your brain, telling you that everything is straightforward, everything is logical, everything makes sense. But in my opinion, you should not trust your eyes. You should trust your hands. If your hand can do it, that means you can move on to the next problem. Okay, so when you see a solution, read everything, every single step, all the details. If you think that you know how to do it, then put the solution away. Grab a piece of paper and try to solve the problem by yourself completely from the beginning to the end. And you might be able to solve it, right? That's good. You can move on to the next problem. But if you got stuck, which is pretty common, not a big deal. You read the solution again, try to understand all the details until you feel confident you know how to do it. Then put it away again, grab a piece of paper and do a few times until you are able to solve it completely by yourself. If you practice that strategy of using solutions, then in a single summer, I think you can learn a lot. Problem 1, the highest common factors of all the pairs chosen from the positive integers QRS are 3 different primes. What is the smallest possible value of the sum of QRS? Okay, so in order to have the sum to be the smallest, we want the individual numbers to be the smallest. Of course, their factors should also be the smallest. What are the smallest primes? Of course, we know they are 2, 3, and 5, right? And each of them is shared by 2 numbers. So we can use 2, 3, 5 to construct a QRS. So for example, from 2 and 3, we can get Q equals 6. From 3 and 5, we can get R, which is 15. We multiply them together. And from 2 and 5, we obtain S, which is 10. 2 times 5 equals 10. So the sum is 6 plus 15 plus 10, which is 31, right? So this question is not that difficult. Problem 2. The following is an equiangular hexagon. That is, all its interior angles are 120 degrees. 4 of its sides are 7, 6, 3, and 5. What is the side length of Y? we see that it's a hexagon. A hexagon is not too bad. And the angles are 120, which is nice because we like 120, 60, 30 degrees. They are so special, right? We know a lot of things about these angles already. We don't have although we don't have a regular hexagon, but the angles are pretty nice. So this is what we have, this shape. You know, when there's no clue, just try. Don't be afraid of a try. So for example, let's extend some lines to see what do we get. Let's extend the top one to the right and the right one upward. What do we see? Aha, we have an equilateral because 120 degree, 120 degree, and 60, 60, of course, is 60. So once we have a equilateral, so immediately I want to put the numbers on the sides. So we see that we have an equilateral, and immediately we notice that we can construct two additional ones. So this one side length is 6, and the smallest one. For the smallest one, we don't have information to know a side length. But if they look at the whole thing, we just jump out of the hexagon. What do we see? We see a giant equilateral. Do we know the side length? Not from two sides, but there's one side we have all the pieces we need. So it is 6 plus 3 plus 5, which is 14. And if we look at the left side, we have 7 and 6 already. So the side length of the smallest equilateral must be 1, and this must be 1. Now let's look at the top part. The top side of the giant equilateral also has length of 14. We already have 1, 5, so y must be what, 8, right? So 1 plus y plus 5 equals 14, which tells us that y is 8, which is C. Okay, so so in the way that I extend the lines, I got a giant equilateral. This is not the unique way. You can be creative, you can use other methods as long as you follow some strategies. Try to find something special so that you can know, you can make use of the information that is given. Okay, so for example, let's try another way. So I'm going to erase what we have already. If you tell me this shape and ask me what kind of a regular shape it is close to, I don't think my first impression would be, my first guess would be an equilateral. My first guess would be a parallelogram. So if I extend the bottom one to the right and the right one down, and for the upper left triangle, I also make an equilateral. So what do you see? It is a parallelogram, right? It's very easy to verify that there are 2 pairs of parallel lines. Okay, so for a parallelogram, we know that the opposite sides have the same length. And before that, so let's just write down the numbers we already know, right? So 3 and 3. So this part, it is 9, and this side length is 8. And for the left one, because parallel to the right one, so it should also be 8, which means this is 1, which means the top little one is 1, and the top horizontal side length of the parallelogram is 1 plus y, but it has to be 9 because it's a parallelogram. So 1 plus y equals 9, which also tells you that C is the answer, right? So be creative. When you see something you don't know, try different ways. So for this one, why do I make those extensions? Why should I extend the lines in that way? Because it still gives me equilateral, parallelogram. Those things are much easier than some arbitrary shapes. Problem 3. we have a rectangular box. AB equals M, BC equals N, and AA prime equals K. We know that the three numbers are three different even integers and cross along the surface of the box. If the length of its shortest path from A to C prime is 10, what is the volume of this rectangular box? Let's see how we should use this information. We know that the shortest path from A to C prime has a length of 10. When we think about the shortest path of 2 points, we typically just connect them. If we connect them, this doesn't work because we know that the end cross along the surface, not inside the box, so that doesn't work. Okay, so it seems reasonable that we first, the end first cross from A to C, then from C to C prime, then it will remain on the surface, right? With that, we can write down M squared plus N squared from A to C, and then plus K equals 10. If you try to solve and you also notice that M and K need to be different even integers. You will not see a solution. And in fact, this is not the shortest path. To find the shortest path, we need to think about that the end is on the surfaces. And to find the shortest path, it is easier if everything is flat. So for example, let's look at the two surfaces, A, B, A prime, B prime. Suppose that the end chooses to first use this surface and then use BC, B prime, C prime to get to C prime. What is the best choice? It's easier if other surfaces are flat, right? They're on a two-dimensional space. So what we can do that, we are going to fold and fold them. Let's unfold these two surfaces so that it is flat. Okay, and with that, we know that the shortest path between A and C prime is just connect them, right? And AB is M, AA prime is K, BC is N. Therefore, we have a square root M plus N squared plus K squared is 10. Of course, it's easier if we work on the squared of both sides. 10 squared. The right-hand side is 10 squared. This reminds us about the 3, 4, 5 right triangles, which means that on the left-hand side, one should be 6 squared. The other should be 8 squared because we want to look at the integers, right? So M plus N, so let's do 8 squared, and K is 6. Of course, they add up to 10 squared. Let's try to find different even integers for M and N. We know that M plus N is 8. If we do 2, 6, it doesn't work because there's a K is also 6, right? The three numbers need to be different. If we do 4, 4, it doesn't work either because there are 2 4s. So this doesn't work either. I think we have made some intuitive assumption, but which is not necessary. We're thinking that, okay, M and N, there are 2 numbers, so their sum should be greater than K, which is not necessary. So let's try the other way. If M plus N is 6 and K is 8, for 6 we can use 2, 4, which is perfect. If the three numbers are 2,
or 8, then the shortest path has a length 10. And the corresponding volume is 2 times 4 times 8, which is 10, right? So we're done with this problem. So you might also suspect that, are you sure this is the shortest path? What if the end first chooses A, B, C, D surface and then use another surface? In fact, it doesn't matter. So for example, if the end first chooses A, B, A prime, B prime, which is the one that we just looked at, and next, if it uses A prime, B prime, D prime, C prime, which gives this one, then you just have a different equation. The orders of the M and K values will be different from the ones that we just had. But anyway, so M, N, and K, they're from 2, 4, and 6. I mean 2, 4, and 8. So it really doesn't matter which one, because we want to look at the volume, which equals the product of the 3 numbers. If we look at the total number of ways that we can try, so you see that we have this blue one, which is the one that we used in the previous slide to solve the problem. And the other one is, there's another blue one. So you can also have the 2 red ones and the 2 green ones, right? So this is the 2 red ones. So as I said, it doesn't matter. The only difference is the order of M and K, because we are looking at the volume. Okay, so it doesn't matter which one is which one. So interestingly, there's a more general problem. It's called the spider and the fly problem. You can find it from the Wikipedia. So this is a more general problem, and the setting of this problem that there is a spider, there is a fly, they're on the opposite sides of a box, and what is the shortest path? Okay, so intuitively you think, okay, the path shown in 1, this is the shortest one. That is, you know, intuitively, right? Because both of them are straight. But unfortunately, that is incorrect. So this one, it seems like, you know, you're doing zigzag, but this is the shortest one. So the Wikipedia page shows you the problem. It also gives you the solution and some numerical examples. I hope you will enjoy this more general problem by reading the Wikipedia page. Problem 4 is a number puzzle. Let's read the problem together. N is an even 2-digit number. If the last 2 digits of n squared are the same as n, what is the sum of digits of n? Okay, so n is only 2 digits, which is easy. We can express n using a and b, 10a plus b, where b is the unit digit and a is the 10th digit, right? And n squared is 100 a squared plus b squared plus 20 a b. Because the last 2 digits of n squared are the same as n, it tells us that if we look at the difference, if we subtract n from n squared, the difference is divisible by 100. N squared minus n, let's write it down, is divisible by 100. It's a multiple of 100. Okay, let's take the difference. When I write down the difference, I want to consider the best way to group the items, right? Because we have a 2 plus 3, which is 5 items. First, I want to write 100a squared, because this one is already divisible by 100, which means that this item does not contribute any information to A and B. And then I look at b squared minus b, and so this one doesn't have any tens, and the remaining one it has 10a times 2b minus 1. So the first one, it does not contribute to any information about a and b because it is already divisible by 100. And if we look at the last one, 10a times 2b minus 1, it does not contribute to our searching for the last digit because it's already divisible by 10, it's multiple of 10. And the middle one, this one, it contributes to the unit digit of n squared minus n, because this is the only place that you can obtain a unique digit. Because we already know that n squared minus n is a multiple of 100, which means that the last digit must be 0. Okay, so that means b squared and b have the same last digit. And that narrows down the choices of b, so b can only be 1, 5, 6. But we already know that n is an even number, which means that the last digit b must be even. So we can cross out 1 and 5, which only leaves one possibility to us. And with that, b squared minus b is 30. And the last item, 2b minus 1 is 11. So we have a 1, 1, 0 times a. So we want this sum, 30 plus 1, 1, 0 times a, be a multiple of 100. And the only possible way is a is 7. So a is 7. Now we have all both the numbers we need. One is 7, one is 6. So the answer is 13. So not too difficult, right? In this method, we used a and b as variables. So next, we're going to present another method. In this method, we're going to use reasoning rather than algebra. Okay, so we know that the last two digits of n squared are the same as n, which means that the difference between n squared and n, which also equals n times n minus 1, is divisible by 100. We also know that n is an even number, so which means that n minus 1 is odd. If we look at 100, it equals 4 times 25. Because n minus 1 is an odd number, so 4 should come from n, which means that n is divisible by 4, right? Now, where does 25 come from? If it is come from n, then n is at least 100 because it is already divisible by 4. That means that n minus 1 is divisible by 25, right? Okay, there are not that many choices because n has to be 2-digit. N minus 1 can be 25, it can be 50, it can be 75. 25 means that n equals 26, but this is not divisible by 4 because we know that it has to be true, right? And in the second, if n minus 1 is 50, n is 51, that is not possible because n is an even number. Lastly, if n minus 1 is 25, n equals 76. This works, right? In fact, this is the only answer. With n equals 76, the answer should be 7 plus 6, which is 13. Problem 5 is a mathematical riddle. it asks us to find out how to represent the decimal number 2000 using a new system. Is the base -2 system. The person who wrote the problem must be a person who likes negative numbers so much. But it bothers me because I'm not familiar with the system, and also it's mainly because that I don't feel confident about the place values. Because of that, let's starting with looking at the place values. That is, for a specific one, let's look at what value does it represent in the decimal system. Okay, let's start from the first one. 1, it is still 1, no matter which system you use, right? So the 1 in the -2 notation, it is still 1. If we add a 0, what is that 1 means? The place value. It is -2 to 1, which is -2. Let's look at the place value of 1 in the 100. This one, it is -2 to 2, which is 4. If we add another one, we got -2 to 3, which is -8. And now we see there is pattern, right? It alternates, the sign alternates from negative to positive. So I decided not to write in the -2 notation because it's too much. And because I needed to find out how to construct 2000 using the system, I needed to know the decimal values. So after -8, I have 16, and then -32, and +64, -128, +256, -512, +1024, -2048, +4096. Because we need to find out 2000, the last 3 digits are pretty close, so this should be enough, right? We want to rewrite 2000 using the numbers from 1 to 4096. We see that although the absolute value of 2000 and the -2048 are the closest, but we cannot use it directly because it's negative. So we have to use a larger number and then subtract it, right? With that, it's still 48 more. But -48 is not in the system. We have to rewrite -48. Okay, so I see that -1 to 8, that one is the closest. And to make -48, I need 80, right? But 80 is not there either. How can I make 80? So I see that I can use 64 and 16. Okay, now I'm good. All the numbers are in the system. 4096, -2048, -128, 64, and 16. For each of them, I need a 1. Altogether, I need 5 ones, which means that altogether, there are 5 non-zero digits. So the answer is 5. So there are 5. We need 5 ones. Of course, each one has different place value, right? So the answer is 5. This is a geometry problem with information about area. In this square, the total area is 100. With that easily, we can write down the side length, which is 10, right? And then next, we also know that the whole square is divided into 5 regions of equal area. which means that the area of each triangle is 20. With that, we can find this part is 4, and the height of this triangle is 4, and the height of this triangle is also 4, right? I would like it, okay, let me just redo it a little bit to make it a little bit nicer. One thing I would like to remind you that a lot of times don't be cheated by the picture. For example, in this figure, you see that, let me write it down the number, let me add some letters. We have A, B, C, D, E, F, G, H. You might need more. P, Q. We see that EQF and FPD, they look similar. They have the same area. They have the same base and height. But in fact, these two triangles are not similar. With the information that we're going to add, you will see that they're not similar at all. On the other hand, if you just think that they look similar, so you just assume that they're similar, you're going to end up with some wrong results. Okay, so for information that you cannot conclude, then do not use it. I mean, you know, if you really don't have any other hope, then you can try, but else it could be, it's a risk. Okay? Okay, so let's see what do we have. After adding the two heights, we have some similar triangles. In fact, let's also add this height, although we don't know the length yet. Now we see pairs of similar triangles. Let's use red color. You see this little one, EGQ and ACE. They're similar. And the ratio is 4 to 10. So 4 to 10 equals the H over 4, which is AC. So this one is AC. The other one is QG. And this tells us that EG is 1.6. Okay, 1.6. Therefore, FG is 8.4. Okay. And next, we see another pair of similar triangles. I'm going to use green. You see this one and the larger one. Can we find the ratio? We see that one leg pH is 4. The corresponding leg in the other triangle is FG, which is 8.4. Therefore, we have 4 over 8.4 equals FH over 4, which implies that FH is 16 over 8.5. Let's times 10. And we cancel 4. Cancel 4 is 40 over 21. So this piece is 40 over 21. But because F, H, and HD, they add up to 10, which tells us that HD is 10 minus 40 over 21 is 21, 170 over 21. So HD and the height of FB are the same. We know that the triangle PBD also has area 20, which means 1/2 times BD times 170 over 21. This is 20, which implies that BD equals 484 over 17. And because AC is 4, AD is 6, that tells us that AB equals 6 minus 84 over 17, which is 102 minus 84 over 17, which is 18 over 17. So the answer is B. Here's another math riddle or puzzle. This problem appears in both AMC 8 Plus and AMC 10 and 12 this week. I'm going to use two methods. The first one is I call it forward method. I start from just the 3 digits and see whether it works. If it is not, I'm going to add one more digit. I try to find some pattern or some shortcut until I'm able to find the smallest n I need. So this method is more accessible to AMC 8 students, as you don't need to use a lot of variables. In the second method, I call it a backward method. I start with a general situation. I don't know the number of digits. I use a variable. Then later, I'm going to see which conditions do the variable satisfy. After that, I'm going to figure out what is the last digit. Then the second to the last until I find all the numbers that I need. Okay. Let's read the problem again. We have n is a positive integer. Last digit is 7. And if we move it, the new number is 5 times 7. Okay, so the old number, it ends with 7. The new number, it starts with 7. Because it is 5 times, so the first digit of the old number must be 1, and which means the second digit of the new number must be 1. Okay, so we don't know how many digits between 1 and 7 in the old number. Let's just assume that there's only one digit, we call it A, and see whether it works. Okay. So 5 times means that 710 plus A equals 500, then 50 times A, then 35, right? So let's rearrange them. We have 210 minus 35 equals 49A. Okay, let's simplify it a little bit further. So we notice that the left-hand side, we can take 35 out. So we have 7 times 5, and 6 minus 1 equals 49A, which also means 5 times 6 minus 1 equals 7A. The right-hand side is a multiple of 7, but the left-hand side is not. Clearly, one single digit between 1 and 7 does not work. Let's try two digits. 1, A, B, 7, and the new number is 7, 1, A, B. And again, let's use the relationship of 5 times. We can rewrite it again, and you will see that it's 5 times 60 minus 1 equals 7 times 10a plus b. The right-hand side is a multiple of 7, but the left-hand side is not. Because 59, 16 minus 1, which is 39, it is not divisible by 7, so this does not work either. Before we continue, let's see whether we can make the reasoning shorter. So we notice that here we only need to look at the 6 minus 1. If 6 minus 1 is divisible by 7, then it'll work. If not, it does not. And when there are 2 digits, we only need to look at the 60 minus 1. And in fact, if you work on 3 digits, we need to look at 600 minus 1, which is 599. 599, if you try to divide it by 7, you will have a remainder, non-zero remainder. And if you look at the next one with 4 digits, it is 5999, and let's divide it by 7. It is 5639 53549. Perfect. So with 4 digits, it will work. Okay. Next, let's look at a 4 digit. The old number is 1, A, B, C, D, 7. And the new number is 7, 1, A, B, C, D. 5 times means 7, 1, 4 zeros plus 1008 plus 100 times B plus 10 times C plus D. This equals 5 zeros plus 5408 and 5000 B, 500 C, 50 D. And again, let's simplify it. You will see that it's 5 times 6000 minus 1 equals 7 times, sorry, there's 7. 7 times 1008 plus 100B plus 10C plus D. Because 5999 is divisible by 7, and we just found that this equals 857. Once we find the product of these 2 numbers, let's multiply them together. We should be able to find A, B, C, D. Which means that A is 4, B, sorry, this is A. B is 2, C is 8, D is 5. The original number, therefore, is 14285. The question asks, what is the sum? 10, oh, there's 7, another 10. So the sum is 27. This is the answer, right? The second method, I call it backwards, because I started from finding the last digit, and each time I find one more, go backward until I find the first one. In this method, we need to use a set of variables. So this is more general than the AMC8. It should be able to solve more general questions. But for AMC8 students, probably they are not familiar with variables or using a larger number of variables. Okay, so between 1 and 7, we don't know how many digits there are. So I just assume that there are k of them, and I use A1 through AK to denote the digits. So this is the old number, and the new number, it is 7, 1, A1, dot, dot, AK. And also, to make it convenient, I want to define the value. So for example, I use bracket. So this bracket A1 through AK is the value with digits A1 through AK from left to right. So this is the value. And we know that the new number is 5 times the old one, which means 71 times 10 to k, and plus the value of the remaining part. And this one is 5 times 10 times 10 to k, and then 10 times A1 dot dot AK, and then plus 7. Okay, so if we rearrange them, we have 21 times 10k minus 35 equals 49 times A1 dot dot through AK. And we see that there is a common factor 7. So let's get rid of 7. 3 times 10 to k minus 5 equals 7 times A1 dot dot AK. Note that the number on the left-hand side ends at 5, which means that AK must be 5. Else, if you multiply 7, you cannot get a number that ends at 5, ends with 5. So this implies that AK is 5. The last digit must be 5. Now, let's substitute AK with 5 and see what we have. So this is 70 times A1 through AK minus 1. We drop the last one, and 35. Which gives us 3 times 10k minus 40 equals 70 A1 dot dot AK minus 1. Now we can simplify by dividing by 10 on both sides. The left-hand side, we have a number that ends at 6. The right-hand side is multiple 7. Which digit times 7 gives you something 6, which is 8, because 7 times 8 is 56. So this tells you that AK minus 1 is 8. We find the second to the last digit. And now substitute, we have a 70 A1 dot dot AK minus 2, then plus 56. So again, we want to simplify. We have 3 times 10 to k minus 1 minus 60 equals 70 A1 dot dot AK minus 2. And further, we have 3 times 10 to k minus 2 minus 6 equals 7 times A1 dot dot AK minus 2. You see that the left-hand side ends with a 4. The right-hand side is multiple of 7. 2 times 7 is 4, which means that AK minus 2 has to be 2. So let me rewrite it to the next page. is 2. And with that, we have 70, A1, dot, 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 AK minus 3, then plus 14, which leads to 3 times 10 to K minus 2 minus 20 equals 70, A1, dot, 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 AK minus 3, and divided by 10, 3 times 10 to K minus 3 minus 2 equals 7, A1, dot, 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 AK minus 3. The left-hand side ends with 8. The right-hand side is a multiple of 7, which implies that the last digit, which is AK minus 3, is 4. Okay. Now, when it is 4, what do we have? So this is 70, A1, dot, 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 AK minus 4. Then here we have 28, and let's see. So this tells us that 3 times 10 to K minus 3 minus 30 equals 70, A1, dot, dot, AK minus 4, which implies that 3 times 10 to K minus 4, and not yet. You see that the left-hand side, when K is 4, is 3 minus 3, we can end it here. The right-hand side, we don't need any digit. So which means that this is done. If K equals 4, we don't have a negative 1, right? So which means that K, it is 4 because it is satisfied and it is the smallest one. So in summary, we first find the last digit, which is 5. Then the second to the last one is 8, then 2, then 4. If we add all the digits, the sum, again, it is 27. So the same answer.